Hi, my name is Merlin. Today I'm gonna talk about what I learned today. So actually, yesterday I talked about like the minimal Rust kernel, and also, I was like hard to able to understand what is like bootloader and what is some kind of kernel. And yesterday I also talked about the what is the hard disk. So today I'm just gonna talk about the questions while I read this journey in creating an operating system kernel. So the thing I was kind of curious while reading this here, where was it? And this part. So there's like this is. I'm just gonna zoom it. So I was kind of like curious about why we divide into AH or AL. What? Yeah, so but that was my question is why we have to know about like high and low bits. It's kind of because it's kind of more increasing flexibility because sometimes you only need to store into just one small byte, and that means like you don't have to store one small size of the data into 16 bits. You can just only put in the 8 bits, which is AH or AL. So that is why we have to separate it. And also, oh yeah, this one is really interesting. So I think this concept is widely used. Wait, hold on. Not here. I think I have to increase this. Where was it? 11. So in here, this ELF is, or I think this is really important concept because this is, or I've seen this word in other blog like writing Rust in the writing operating system using Rust, and this ELF is just like way of organizing the way of organizing. So organizing what? It's just like, so there's like executing file. So it's like ELM is just like a bundle in some kind of in web development. It's similar to bundle. So which is there's like machine code and there's our metadata, and these are like this like bunch of things are called ELF, executable and linkable format. You just so when you turn to like understand what this ELF means, it like ELF seems like really abstract and seems like hard concept. Like ELF executable, like linkable format. It's just like it is executable and linkable. Machine code of your file and metadata. Just like it. And also it's just like binary file. It's just a format. So the reason why it's a binary format is just the format of the binary file. So which means that you're in the Linux there's a binary format in the Linux and there is binary format in the Windows and Mac. So based on that, so that is it. So ELF is kind of different in the Linux and like other things are different in the Mac. So the thing we have to know about when you're trying to make an operating system, we have to make our binary format into compatible with the other environment. So we have to just know this first. And also, my question was, while reading this here, what is fat? What is fat right here? Like due to that, where was it? Yeah, here. Like there's kind of like hard concept, like fat ELF. So fat ELF is just like a generic binary file based on the process architecture, ARM or x86. So it's using binary file. So fat ELF it's like just compatible with the environment that you have, and fat means that not just fat like eat and fat, So FAT just means like multiple version of for the some specific architecture. Example, if your binary file could be different version in x86 and ARM architecture, and these format is also known as FAT. If you have two versions of it, that's called FAT binary. Like if your binary has two versions, multiple versions of based on the some specific architecture, that's called the FAT binary. And flat, so you're saying that our binary should be flat. The flat means that it is pure machine code. There is no some kind of binary format. It's just pure code, like a bin file. And also, you might cannot understand like the last output means, like, because in some sentence it's saying that beside the compiling and recompiling steps, an important step needs to take place in order to generate the last output. This operation known as linking, and last output is just like the final executed file, like an entry point. Like if you're a web developer, you're like very familiar with the entry point, like index.ts, main.ts. So that is very simple. So linking is just like bundler in the web development, just like collects all the dependency into one single file. It's just something like that. And building process is just like compiling, assembling, and linking. So and also the thing I was really also curious while doing this here, it's saying that usually the goal of the bootloader is loading the kernel of an operating system from the disk to the memory, and it gives the kernel the control over the computer. My question is, how does it give current control? So here's the thing. It just like gives like control like some kind of modern way. It's like, but it's like jumping into kernel's entry point. Yeah, it's just like jumping, because like bootloader there's an entry point, and after bootloader locate the kernel's entry point and start executing. So that's kind of simple. And and the thing also my question was, it's saying about limited size of like hard disk, because first sector is and the sector is 500 terabytes, and my question is, why don't we use two sectors? Yeah, why? Because of limitation, we can just increase the size, like two sector, right? We can use those two sector. We can increase the size, right? But the thing is that this specification is related to the BIOS, and you have to configure BIOS to make it like using a two sector, and that could be a really tedious job. So there's kind of a lot of issues of it. And hard disk, like pan here, like there's ARM here. It's like, imagine like a record pan. So in like 90s or 80s, like 70s, 60s, they're using like CD here, like not CD, like just a really big pan, and they put like some kind of needle thing, and if they click it, it just like moves it, and this kind of needle rotates it, right? So like it's like similar to the hard disk, are like not same but similar to this, and the ARM are moving same direction. And also I'm just gonna skip the unnecessary part. And also, and the reason why I like this this book, it's really compact, and it really says about core thing, the glance on computer science. So the machine code is located in the memory, makes CPUs to execute it. And also, that was really interesting. So x86 use it for Neumann architecture, and others are like, I think Linux use it for hardware architecture in the hood. I thought like for Neumann architecture or like hardware architecture, it's just like I thought it was just only theory. It's not practical. I thought, but it was. It is. It's actually everything. Computer science is just core thing. We in Linux or Mac are using this concept under the hood. It is practical. Like economics, it's not practical. If you're trying to learn about business, the economics theory is not practical, but this one is. It is. So that was really interesting for me. There's only a little bit. 30 minutes. So I was reading the blog. I'm just gonna explain the core thing. The 7% make. I'm gonna finish it to the here, like not here. Here, make it. It fills. Hold on. I'm just gonna explain the core thing. So the reason it fails is because it's saying about like Rust compiler as a pre-compiled library, and there's so many things. So the reason it fails is that normally we write the Rust code or C language or C code, and we compile it. It means that before it runs the code, it converts whole code into machine code and execute the machine code, right? That's how compiler works. And the thing is that there is pre-compiled version, like some kind of core feature like STD. Before even we run it and transfer to machine code, there is already pre-compiled code. So which means that if we compile the code, it based on our architecture, our new target architecture, but pre-compiled code is not compatible with our target feature if we change it. So that means that we have to recompile it. So that is, it's like, how do I say it? It's just like built-in code, but that is not compatible with the other environment or other target. So we have to just recompile into make sure it change it to into this kind of environment. I'm just gonna give the example. No, never mind. So this is it. Because my battery is so low and it's already late today. So tomorrow it's gonna be like different. So bye bye. See ya.